Hi, I'm Deneen, and I'm so glad you're here today because this is a very timely math lesson for this week. And I have wonderful Stanley with me who's going to take us to the next level of understanding, I hope. On Monday night of last week, I was getting ready for bed, 9 o'clock. I was so proud of myself because I was actually going to get in bed before 9:30 and hopefully be asleep very soon. When my friend Heather Page, who teaches with me at my school, sent this message to me and said, Deneen, tomorrow is triple square day, 9/16/25. It's like, oh my goodness, that looks so cool. Now bed plans are gone and we have to figure out what we're going to do to make this day special. And what we came up with was she would go to the store in the morning and buy Cheez-Its, a bag for each student, and we would have them work with Cheez-Its making squares. So we had them make 2x2 square, then 3x3 square, 4x4 square, 5x5 square. And I love these kinds of lessons because they're so differentiated inherently. I spent so many years teaching students in small groups for mathematics instruction because I had, the varied levels and it was so hard to teach them all at one time. But the way I teach now with more hands-on activities out of the textbook, it doesn't matter. The students will fit where they are. Case in point, Destiny was really struggling and she said, Mrs. Matsuda, I don't understand what I'm supposed to do. And I try so hard to always respond to those kinds of questions with, I'm so glad you told me that and I'm so glad you don't understand because now we have a chance to work together. And so I sat down and we worked, and the joy and pride that she experienced when she figured out how to make the squares, she just kept making rectangles over and over again, just filled my heart. And then we had Michael, who in the same lesson figured out the pattern so quickly he was able to go to 10-10 on his whiteboard and far beyond. Another question that we asked was, given the Cheez-Its that you have, what is the next square that you could make? And then an even more open-ended one would be, how many more Cheez-Its would you need to make the next size square beyond that? And they could combine their Cheez-Its if they wanted to. I also pulled out my little 1x1 inch square tiles, and I bet your kindergarten teacher has some of those that you could pull out. So it was a great day, and I explained to them how 3 squared, 4 squared, 5 squared is 9 September, 16 the date, 25 the year. And it was kind of a rush lesson. We did it in less than an hour, and it was off to lunch we go. And I was feeling really great. I was able to go onto the ladies' website that my friend had sent me the picture of. It's called Rise Over Run, and she has put together a packet of triple square day activities that go all the way from 5th grade into high school, and it's free. So I would encourage you to get that. And I started looking at it through the week, and I thought, I want to revisit this again. So on Thursday of the same week, I said, it was so much fun learning about squares with you. Let's keep learning about it. So I copied this paper off for everybody. And then we talked about it, and then we put in our math journals, we made a little chart where I had the standard notation, the expanded notation, and then the exponent notation. And as we were doing this, all of a sudden I heard this sound of, oh. And, that's the sound, that's the best sound a teacher can hear, right? And we kept going, and then another student about 5 minutes later did the same thing. Oh! And as we went on, more and more students were saying that sound, making that sound. And so I finally just stopped and I said, all right, I'm going to ask you a very scary question right now, but on Tuesday when we were studying about the triple square day, would you please raise your hand if you really didn't understand what was going on? And a majority of the students raised their hand. I said, okay. but you're understanding it now. And they said yes. And, that really made me happy. But it also was interesting to know that on Tuesday, people were enjoying it. Even though they weren't fully understanding, they were experimenting and exploring with numbers. Nobody was crying. Everybody was having fun. So we don't have to completely have mastery of understanding to enjoy ourselves. We glued this in our math journals, and some of the students wanted the whole thing up to 10 by 10, so they just folded theirs over. Now,
wait. There's a mistake here.
There is? Of course. Because mistakes are an important part of learning, Stanley.
Okay, so if you look at this one, it's supposed to be 100 expanded 10 times 10. And exponent form is not 100 squared, it's just 10 squared.
Oh!
You just added an extra 0.
I did. Okay. Well, I'm not sure if my students did that. Maybe
you better double check.
We'll double check that. We'll revisit that. Thank you. That's why he's here. As I was going through my packet, and next week I want to do this because guess what? There's another square day coming up on next week. It's Thursday. It's 9/25/25. So even though it's not as unique as 9/16/25, I think it's still going to be really fun to go over. Oh, and before we ended our lesson, I said, now we have missed some other square days this month because it's 9/25. This is a really unique month in mathematics. So what other dates have we missed? And I had them take out their whiteboards and I said, we really have to think about this. So I wrote 9 and a box and 25. And I said, what date could we have put in here to be another square day? And they thought of 9/1/25. They thought of 9/4/25. And I said, 1 is coming up next week. And they got it. It's 9/25/25. So I'm going to give them this blank version next week, and I'm going to have them fill it in. They can color it and write numbers in there. And I also found this in her packet. She had a bunch of other things that were in high school level that I didn't understand, but this caught my eye, and I made it, and I know it has to do with a squared, b squared, c squared, but I'm like, can we do this in elementary school, Stanley? Can we experiment with this at all? Because I really want to, but I don't understand it. So I'm revealing my ignorance to you right now.
Okay, so she's doing triple square day, which was September 16, 2025, or just 25, so 9/16/25. So each number is a square. So we have 3 squared is 9, 4 squared is 16, and 5 squared is 25. But 3, 4, 5 is a Pythagorean triple, which means that on a right triangle, here we have a right triangle.
And we need to teach right triangles because this comes up on map testing all the time. Acute, obtuse, right?
Okay, so on a right triangle, if the leg is A and the other leg is B and the hypotenuse is C, then A squared plus B squared equals C squared. That's the Pythagorean Theorem. So if the numbers are, like if you square them and they're nice and whole numbers, then we call them Pythagorean triples. So 3, 4, 5 is a Pythagorean triple, which happened to be also a triple square day. Okay? So
it was just fun.
You're just trying to combine two ideas together. But like September 1, 2025 is just a triple square day. It's not a Pythagorean triple.
Got it.
Okay?
Should I even mention Pythagorean to them? Or should I?
Well, for this exercise, you're going to have to talk about the Pythagorean triple because that's what this is trying to explain. So 3, 4, 5, one leg is 3 units long, another leg is 4 units long, and the hypotenuse is 5 units long, and that makes a right triangle. And if you square the legs add them together, it'll equal the hypotenuse squared.
And I actually did that at school. I did
Okay.
9.
Yeah.
No, I did 9 plus 16 equals 25. And
Okay.
I don't
Yeah.
understand it, but I was very excited.
So that's the Pythagorean theorem. And because the numbers are nice and whole, it's called the Pythagorean Triple. Okay, now when you do the Cheez-Its in the 5x5 or a 4x4 and a 3x3, and you line it up like this is like the beginning.
We could have done this with our Cheez-Its.
You could if you have enough Cheez-Its in the bag. But this is
There are enough.
This is like the beginning of the Pythagorean theorem proof. And for those of you who are in high school, you may be teaching this to your students on how to prove the Pythagorean theorem using the area of the squares created by the legs and the hypotenuse.
Maybe if my 4th grade teacher had done this kind of thing with me, I wouldn't have struggled so much in geometry.
Yeah, I don't know.
Something to think about.
But anyways,
Plant seeds.
I'm just talking to the high school teachers. So a couple years ago, 2 high school students I guess they found a different way to prove the Pythagorean theorem. And it was like this huge breaking news because some of the proofs of the Pythagorean theorem use circular logic, which means it's like in a circle. So you use something to prove something, and that proves what you started using at first. So you're just going around in a circle. So people don't like that. But this one is not circular, so I don't know what the problem was. But these 2 girls from high school proved the Pythagorean theorem.
Did you say girls?
Yeah, they're
Why
girls.
does that make me so happy?
I don't know. Hey, honestly, all the girls in my high school teaching career in math were the brightest. It wasn't the guys. I think the guys are too focused on sports or something. I don't know. Or they weren't.
Or the girls.
Whatever. Yeah, that more like. Anyways, okay, so these 2 girls found a different way to prove the Pythagorean theorem without using circular logic. And you just have to just Google Pythagorean theorem proof by high school students or high schoolers or whatever, and you'll get their article that they submitted. So, anyways, just a little tidbit information.
So I don't know how many high school teachers we have that are in our little community here. So if you would like to share this with your high school teachers at your school, that would be wonderful because honestly, I don't know that high school teachers, they're, I think, generally syllabus focused and textbook, getting through the content that they have to do. And but they can still sprinkle in bits of this kind of fun too.
Sure.
Well, before we go, I just want to end with two more things. Aiden came up to me at the end of our day 2 of this, and we have math right before lunch, and it's so fun because every time I say it's time now for us to get ready for lunch, the students are always, they whine, they go, "Ah," they don't want to end math, and he was feeling that way, and he came to me and asked me, he said, "I have some comments and questions," and I actually recorded it, so I'm going to have wonderful Stanley play that for you right now. But just to show you how one little lesson can reach students wherever they are, whether it's in the most basic forms, the planting of seeds, to just really expanding. When we teach this way, we hit everybody, and that is the goal. And then lastly, when this happens again is going to be in the year 2036. Now, I will not be teaching in 2036.
Wait, no,
Wait.
they're You mean triple square day or
Yes.
Pythagorean triple day?
Well, I don't know. When there's another year that ends that ends in a square day, it's not happening until 36, right?
Maybe. I don't know.
Yes.
There's a lot of Pythagorean triples.
Well, yes, I wrote them down. 3, 4, 5, 5, 12, 13, 8, 15, 17. These are all Pythagorean triples, 7, 24, 25.
Okay, so
I don't understand it, but I was trying to
Okay, so
impress him that I could know
Okay, so
these
like
things.
7, 24, 25 is a Pythagorean triple, which you could say is July 24, 2025. Okay, so that I don't know, whatever. There's one in 2026 because I know 26 is the hypotenuse of a Pythagorean triple.
My point is that when the year 2036 comes up, you're going to be able to do special because it's 36, so it's a square. So I think there are going to be special things that you can do. So I told my students, I said, when the year 2036 comes, you're going to be in college. Will you remember this special square number business? And they all said, we will, Mrs. Matsuda. We'll remember you. We will remember. So I just wanted to end with that. Don't think that 25 is the only year that you can do these fun things. Thanks for being with us today, and we hope you'll come back again next week. Have a wonderful week. This is my student, Aiden. Aiden, say hi.
Hi.
And I need to share with you what he just said to me. Go ahead, Aiden, nice and loudly.
I have a comment and 2 questions.
All right, let's hear it.
My comment is
Talk a little louder.
my comment is that I found out that this what was it called?
3 squared with an exponent.
Okay. So it means that
A little louder.
if this was a 9, there's a 3 and another 3, so 2 3s.
So it's 3 by 3. Uh-huh.
And my question is 3 a cube like this 1, 2, and 3?
Yes, that's exactly what it means. In fact, this is called, Aiden, 3 cubed. And that creates a cube, and we'll build one after lunch. We will build one together, okay?
Yay.
Thanks,
And
Aiden.
my other question
Oh, there's one more?
is there a perfect triangle day?
A perfect triangle day. That's a good question. We're going to have to find that out together, okay?
Okay.
Have a good lunch, Aiden.
Bye.
Even though it's lunchtime, I couldn't resist, and I said, Aiden, we have to build a 3 by 3 cube so you can see how many are in it. So go ahead, Aiden. 3 by 3 cube. Had to get out our blocks. We just have to do it. All right, he's at the final stage of building his 3 by 3 cube.
It's like a Rubik's Cube.
It is like a Rubik's Cube, and how many cubes does it contain?
27.
Say it nice and loud into the camera.
27.
So 3 cubed is 27. Now you can go to lunch. I'm Janine Matsuda, and this is my 4th grade class.
Don't forget to like and subscribe.